You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone, and thanks for being here today. I'm Kirk Mona, and joining me are Rachel Gimza and Victoria Thompson. We're all naturalists who together have scoured the world for weird and wonderful wonders, just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Welcome to the show, everyone.
Yes.
Oh,
Hey.
we have a whole gang
Good to be
here.
here.
This is going to be so great. Even though I'm starting with a tragedy.
Oh, no.
No.
I know. In
What's going on?
1912, early
Okay.
hours
The Titanic?
in April. Okay, yes, it was the Titanic. Thank you, Victoria.
Sorry.
Just cutting to the chase. Gonna do a dramatic opening. Titanic. It's Titanic.
Yeah.
We can just start over. You can do your whole intro.
Stolen
No, that
thunder.
was great. Actually, that was so fun. So
Outstanding.
that was beautiful. I think that's the fastest any of us have gotten one of the others, like at least part of one of the others' topics. That was amazing.
Okay.
Wow. So, what's your topic this week, Rachel?
Icebergs?
But it's not about icebergs, although it is funny that I talked about ice and then I went on to talk about the Titanic. It is not about icebergs.
Yes.
It does have to do with the Titanic, however. So famously that it became a movie starring Leonardo DiCaprio and Kate Winslet in 1997.
Mm-hmm.
Saw it in theater. I swear, by the way, when I saw that movie, that the people worked in the theater, like, it was in the winter when I saw it. I swear they, like, at the end when they're in the water, that the staff, like, secretly opened the doors, the emergency exits. It got so cold in that theater. And so you're like shivering while they're in the water. And you're like, is this psychosomatic? Or like, did the staff actually open the doors to the outdoor? I'm convinced to this day, those sadistic staff opened the doors in the winter.
Spoiler alert, Kirk. They wind up in the water.
Oh, yeah, spoiler alert. It sinks at the end.
Uh-huh. Shocking, as this happened over 100 years ago.
Yeah.
Mm-hmm.
Okay.
If you didn't know that part, the story is ruined.
Tragic. So yeah, in April 15th, 1912, the Titanic, which at the time was one of the largest, or it was the largest ocean liner available, it scraped against an iceberg, hit an iceberg, and ended up sinking tragically, with about 1,500 people passing away due to either drowning or the sheer frigidness of the water. It was
terrible. Yeah.
awful, absolutely terrible. It is in the North Atlantic still, at the bottom of the ocean. Historically, not historically, because of the movie, actually, there was a lot of interest that was in the Titanic and trying to like learn a little bit more about it, and like when they found it, like what can we recover, and just learning a little bit more about it.
Sure.
And a lot of anthropologists and such are really interested in the Titanic for other reasons as well. Generally, when a ship sinks, especially in salt water, especially in cold salt water, and I don't know if we've talked about this at all on our podcast. I know I've talked about it probably just in my life, but like people always joke, I live by Lake Superior, which is a large freshwater lake. People always joke about the fact that she keeps her dead. All of the ships and things that have sunk in Lake Superior are still at the bottom. They're still in relatively pristine.
I don't know if they joke about it, but yes.
Yeah, maybe not joke about it, but like
it's a common saying.
It's a common saying.
Yeah.
Generally in cold water, and even you talked about the preservation of this, actually, Victoria, you talked about down in Antarctica when you were talking about, I can't remember the ship, but they found it.
Was it the Endurance?
Oh, Endurance. Yeah,
the
yeah.
Endurance,
Uh-huh.
yes.
Amazing.
Truly. But cold water, especially cold salt water, has a lot of really good preservation when it comes to ships, especially wooden ships. When it's way down deep in the water and down cold, there's not as many like bacteria that can live in that space. There's not much that will eat it, and generally speaking, there's not much that happens and it allows the ships to remain as they were as they sunk, which allows people to be able to, especially anthropologists, love a good sunken ship, because then they can go down and actually figure out, like, especially like ancient ships, like Roman ships, they're able to look back, and ancient Greek, they've been able to see and get the Roman vases out and be able, like amphoras and such, which is really, really, really cool.
Yeah.
But something different is happening on the Titanic.
Okay.
Intriguing.
So around, like I said, it was around a little over 100 years ago that the ship sank, and it's in the North Atlantic. There are quite a few animals that have actually allowed it to, like, become a space for animal. So it creates like an artificial reef of sorts, a nice shelter for a lot of animals to be able to use, right?
Oh, absolutely, yeah.
And it can be used quite a bit, and there's been a lot of research, and it's hard to get down there. Humans famously can't get down as deep as the Titanic. We will explode. But we've been able to use rovers to be able to go and take pictures and things like that underneath, to be able to see everything and see what's going on. And what's happening is bacteria growth.
Okay.
Hmm.
Is that
But
unexpected?
Rachel, didn't you just say
is.
that bacteria doesn't grow well?
Yeah, I did. The Titanic is less recognizable than it used to be because of the sheer amount of bacteria that is eating the rust and eating the metal on the ship.
Okay.
So there's a lot of
I
different
guess where
bacteria.
there's a resource, there's something's going to take advantage of it, right?
Yeah. So it's really wild because this bacteria wasn't even known about, and because it really wasn't, it's a extremophile bacteria, which we've talked about before. But this is acting kind of like a whale fall, and this
I was just thinking that.
It's acting like a whale fall, and it kind of just recently learned about in 2010, and it was recovered from what they call rusticles. So this bacteria creates its own like icicle structure, and it looks rust colored, and this bacteria is eating the Titanic to the point where so it was discovered in 2010, and the bacteria is called Halomonas tyscianae, named after the Titanic. And scientists think that by 2030, the Titanic really won't be there anymore. It's
wow.
By 2030?
That's really soon.
2030, it should probably be completely deteriorated.
What?
Now,
That's
well,
like, so within 5 years, it's just going to be gone like a pile of goo?
Yeah, so they first discovered and isolated it in 2010, and they've been noticing that it's continued to like increase throughout time, and it's really only affecting the metals, not super affecting any of the like wood and everything. That's all still being preserved, but no one thought that this would be an issue because we have wrecks that are over 300 years old. But this is really one of the first like metal ships that sunk.
Oh, okay.
And it went into this area that happened to have this species of extremophile bacteria that is like, rust. This is a great place to be for food. This like a whale fall, and it's truly like scientists think by 2030, Titanic's gonna be gone. It's absolutely wild.
Bonkers.
Mm-hmm.
Completely bonkers.
Yeah. So
gosh. So do they think this is happening with other metal shipwrecks?
I mean,
as well, or just they don't really know?
So far, they don't really know. So far, it's just on the Titanic. But there is thoughts that it could become a problem for like oil rigs and other things that are in the deep sea like that. They haven't noticed it anywhere else as far as I can tell. But it's really wild because what happens is this bacteria actually helps. So rust is when iron or steel is exposed for a long period and interacts with oxygen.
Right.
So when oxygen isn't available, like at the bottom of the ocean, this bacteria actually involves itself in that, and it replaces as the oxygen electron acceptor. So it inhibits, like it consumes the dissolved oxygen and like puts it into the metal so it could eat the metal. So it's taking the oxygen from the water and using it to eat at the metal.
Okay.
So it's helping create iron oxide then, and then it's consuming that?
Yeah.
Oh, I mean, wow. Okay, that's really, really cool.
It's really, really cool. Yeah, they noticed that the Titanic, every time they went down there, it was like, there's some structures on this that weren't there before. I wonder what's going on. And then they were able to isolate it and like figure out what was going on. And it's absolutely wild. But yeah, we might not have the Titanic for very long, even though we've definitely had, but it doesn't seem to affect like wood or anything. It's truly just the iron.
Oh my gosh.
It's wild. There's a lot of like potential uses for this particular bacteria as well, to see what we could do with like aquaculture and like see if there's any like adaptability for its use in other spaces, like maybe even in like recycling of certain things could be helpful.
Sure.
So there's a lot of research that still needs to be done, but it's like there's more and more of this bacteria that's eating the Titanic, and yeah, we can't dredge it up. So fun times.
Wow.
Yeah.
That's super cool.
It's wow. 5 years from now, no more Titanic. Bye-bye.
5 years from now, bye Titanic. That's what I have for you both this week. Is absolutely wild. I came across it. Someone sent me an article and it was really cool. My sources this week were, I got some based off of Wikipedia, but Ocean EDU, which is the Smithsonian website, actually had some really excellent article about the bacteria that live there, as well as Discover Magazine had some really good one, and nextnature.org also had some really great, had a really good article about it as well. So we're going to take a quick break, and when we return, it'll be the tip.
Alrighty, we're back. I'd like you two to come on a little guided meditation journey with me.
All right.
It's
All right.
February, so I want you to imagine that you're somewhere very warm and relaxing. Let's say a tropical beach. Okay.
Oh, I'm there.
you're-
I'm sinking my toes into the warm sand as we
Yes,
speak.
you're lounging in a beach chair. Maybe you're
Yes.
soaking up the sun, or maybe if you're me, you're under an umbrella.
I am absolutely under an umbrella.
I knew you would be, Rachel.
I burn like a
So-
crisp.
Likewise. Close your eyes. You hear the sounds of the waves lapping on the beach, the palm trees rustling in the wind.
This is lovely.
Feel the warm breeze on your skin.
Mhm.
The air smells like sea salt and tropical flowers.
Mm.
You open your eyes again, you see the incredible aqua of the sea over the coral reef and the fine white sand of the beach. Holding your fruity tropical beverage in one hand, you drop the other hand to the ground and let the fine white sand trickle through your fingers. All right, this is where we come back to reality because
There it is.
No, I'm not
No,
leaving.
I'm
not leaving.
with my tropical beverage. I have some nice wet sand that's really fine, that's getting all the calluses off my hands.
I want to
I'm
talk
not
about
leaving.
that sand, Rachel.
Oh, God.
A large
What?
part of that sand
Yeah.
is
no.
actually fish poop.
Why would you wreck
I mean,
this,
yeah.
Yeah.
Yeah, it is. That's a good point.
Yeah, it's thanks to a type of fish called the parrotfish.
I love parrotfish.
Okay. I love parrotfish. You're talking about
munch,
parrotfish?
munch,
Oh,
munch.
that's so
I'm talking
cool.
about parrotfish.
Oh, I have to take it
Cool.
off my list.
I figured you probably had it on your list. I got there first. All right.
It's always
Parrotfish.
deeply satisfying to beat Rachel to an ocean topic.
Yes, it is. Parrotfish are actually a subfamily of about 80 species. They're related to the wrasses.
They're so cool.
Wrasse. Yeah. They tend to be brightly
wrasse.
colored, so they're kind of fun to look at. They can be different shades of blue, green, yellow, red, black, and gray. They are moderate-sized fish ranging from about 1/3 of a meter to 1.2 meters. And their name comes from the beak-like appearance of their teeth. Their teeth are like overlapping scales almost, kind of fused together into plates that look like a beak. A little bit like a parrot's beak, not that much, but kind of. And they use that beak to eat their preferred food, which is algae. They'll also eat other plant matter like seagrasses and also some small animals like sponges, but their main food source is the algae that grows on coral reefs, which is important for the reefs because overgrowth of algae can really smother coral. So the parrotfish help to keep that in check.
Mm-hmm. That
some types
actually
of-
causes a lot of coral to die as part of coral bleaching.
Yeah.
Is the increase of that. Anyway.
Yeah, exactly. Now, some types of parrotfish just use their beaks to scrape the algae off the surface of the coral, but other species also snack on the coral itself. So I'm now getting toward the part about fish poop. But I'm first going to have to do a little review on what coral is. I think a lot of people don't really know exactly what coral is. Like they think it might be kind of a plant or some other weird kind of organism. Not really sure. They don't really understand. But coral is an animal.
Lichen.
Yeah, like lichen, right?
Yeah.
What is it even? Who knows? I mean, people do know,
talked
but
about it
I think a lot of
way
people
back
don't.
In episode
Yes.
2.
Yes. Listeners, if you haven't listened to that and you're wondering what lichen
I'm sorry.
is,
That was
go back
episode
and-
1.
Episode 1.
Episode
Yeah.
1. There you go.
Keep going.
So coral is an animal, though. They're related to sea anemones, a little more distantly to jellyfish. And they're composed of these little polyps that are squishy, but they secrete a hard exoskeleton made of calcium carbonate, which is the same stuff that makes up seashells and eggshells. And, of course, this protects them from predators. However, some parrotfish will actually break off chunks of coral with their beaks and chew them up to eat the polyps.
Yeah.
Chew them up, you say? But it's pretty well known that it's very hard to chew with a beak, right?
Yeah.
So, calling back to another episode, where Rachel talked about something. Rachel, you remember talking about moray eels?
I do.
And
I
their
sang a terrible
terrifying
song.
second set of jaws in their throat, like the alien in the movie
Yeah, I
Aliens.
remember that
Yeah,
too.
yeah.
Mhm.
Yeah. Parrotfish
Yeah.
have them too.
Awful.
Those are called
Hate that.
Yeah, they're called pharyngeal jaws. I'm sure you remember.
Yep.
However, instead
They've
of being
come up
full
a
of
couple
sharp
times.
hooked teeth, and instead of being full of sharp teeth to kind of drag the prey fully into their throat the way eels do, the parrotfish's pharyngeal jaws are more like molars, and they're specialized for grinding up coral into tiny little bits. They grind it up, they swallow it. The parrotfish digests the soft polyp body of the coral, and the ground up exoskeleton gets pooped out as beautiful white sand.
Beautiful.
Yes. They will
Wow.
also take in existing sand and poop it back out to get the algae growing on it. And
Really?
I'm not sure if all the same species do all of that, but in any case, in the Caribbean and Hawaii, the estimate is that about 70% of the sand has been through the gut of a parrotfish. Although I could not actually locate a paper with this specific number. I just saw it repeated on a bunch of websites. So, grain of salt. But based on what I did find, it does seem like parrotfish can, a single parrotfish can excrete like a ton of sand in a year, something like that. So it's a lot.
Oh my! That is so much sand. That's so much poop.
I mean, I had always assumed, because I've been like snorkeling, and you can hear them, scraping. You can hear the chewing. Right? The scraping. But I assumed it was more of a scraping action, and they were letting all of the bits of lime, just fall down
the
like in front of them. Like
some of them are doing that. Some of them are doing that.
Okay.
But some of them are chewing it up.
Okay.
Wow.
Sure.
Yeah.
Why not?
So the pooping out sand thing was.
Sorry, I figured sand was at least some fish poop. 'Cause it's sand. It's in the ocean. Has to be mixed in somehow.
Right.
Oh.
Well, the pooping out sand thing was the main reason I wanted to talk about parrotfish this week, but I did find out some other really weird, fun facts about them.
Yeah.
First, this is really cute, but like all wrasses, they move themselves forward in the water by flapping their pectoral fins rather than moving their tails side to side. So they're just sort of like dog paddling, kind of.
It's so cute.
Also, they are diurnal animals, and some species, to protect themselves at night while they're sleeping, surround themselves with a cocoon of mucus.
Which is so gross.
Yeah. They'll burrow into the sand or like a crevice or whatever, and it's thought that the mucus maybe hides the smell of the parrotfish and may also act as kind of a warning system. So like if a predator gets near them and touches the mucus cocoon, the vibrations will wake up the fish.
Okay.
Their scales also are very large
weird.
and thick and tough. Yeah, and in places where they're taken for food, it makes them very hard to penetrate with a spear if you're spear fishing, and quite difficult to scale. Like, very hard on the hands.
I believe that.
Sure.
The colors and patterns can also vary by age and sex within a species, which makes it hard to tell one species from another. So when taxonomists were first cataloging them, they originally believed there were more than 350 species of parrotfish, but now there are thought to be only around 80.
Okay.
And along with changing color at different times in their lives, they can actually change sex. Most of them do. Most species will start as female and then later become male, but the pattern can be more complex for other species, like back and forth. Nuts.
Sounds fun.
Yeah. They're really cool animals. Unfortunately, as with all animals that live in and around coral reefs, they're not doing so well right now.
Yep.
Yeah.
So a lot of them are threatened.
It's unfortunate.
So, yeah.
They're still really fun.
But when they're around, they can help protect the reefs by eating the algae. So, yeah.
They're so cool.
That's
I
pretty
love
much
those
what I
fish.
have about parrotfish. That's pretty
love
much
those
what I
fish.
have about parrotfish this week. They are really cool fish. You're welcome. My sources this week were the UK Natural History Museum, the Monterey Bay Aquarium had a really good page, and I also got some information from Wikipedia.
Nice.
We are going to take a short break, and then it'll be Kirk.
Woohoo!
Welcome back, everybody. I have a mystery for you this week.
Ooh.
Our story begins in 2007.
Okay.
Victoria,
The
this is where you
Titanic.
jump in. Yeah, there you go.
Right.
So no, this story begins in 2007 with Dr. Duncan Lorimer and his student David Narkevic. They were scouring archival data from the Parkes Observatory in Australia, which I should point out is a radio telescope. And they stumbled upon an unusual millisecond-long burst of radio waves originating from far outside our galaxy. Okay, so like big deal, right? They found a
Quasar or something?
millisecond-long blip of static. Like, so what? Like the entire sky is full of radio static at all times. So why should anyone care about a millisecond blip? Even if it came from outside of our galaxy, right? Well, the deal is this wasn't just
like
a blip of static.
Like, of course it wasn't. This is like bringing something back. It's like I have a flickering light bulb in the back of my head right now, like going, "You've heard of this."
Well, when we receive a radio signal, we can also determine how powerful it was, or to put another way, how much energy it must have taken to create and send it out. Obviously, this is going to depend on the further away it came from, and the stronger the signal it gets here. You can do some math and figure it out. Well, this particular burst, this first one, which is now known as the Lorimer burst, caused quite a stir because the calculations showed that even though it lasted only a millisecond, the radiated energy it represented was equal to the entire energy output of our sun over the course of 3 days.
Oh, wow.
What?
So
in a millisecond.
What? So imagine all of the energy of our sun, minutes, hours, 3 days worth in every direction, concentrate all of that energy into a single burst lasting a millisecond. That's how powerful this was. So clearly something powerful and strange was lurking out in space. Now, after the initial discovery, astronomers worldwide began scouring the skies looking for more of these elusive bursts. And with advancements in radio telescopes and data analysis techniques, the hunt for what we now call a FRB, or a fast radio burst, has intensified. And even though they are crazy powerful when they occur, I do want to point out the signals themselves are extremely weak once they arrive here. I saw one comparison that the signal strength is 1,000 times weaker than the signal output of a mobile phone.
What?
If you were measuring the strength of the signal from Earth and the cell phone was on the moon.
So there it is.
We are talking about extremely weak signals by the time they get here to Earth, but that gives you an idea of how far away these must be to be so powerful, to be so weak by the time they get here. So we're picking things up from crazy far away. We can tell they must be incredibly powerful when they happen, but this isn't something you're going to like tune in your radio and be like, oh, I heard a fast radio burst. It's like they're very, very weak. Okay. You have to have enormous antennas to pick these things up. Now, significant contributions have come from observatories like the Australian Square Kilometre Array Pathfinder, the ASCAP, and what a name. I just kind of said that one out loud for the first time right now. And then the Canadian Hydrogen Intensity Mapping Experiment, which is a much better acronym of CHIME. So in 2015...
That's lovely.
Yes, lovely. Has a nice ring to it. In 2015, there was a game changer that arrived, and that was the discovery of the first repeating FRB, or fast radio burst. So unlike the other FRBs that were these one-off events, this particular burst with a great name, FRB 121102, it emitted multiple bursts over time. And you could like go back to the same well, you could look at the same spot, and you could measure multiple bursts over a period of time because it would go off again. So this was like, ooh, this is another clue. This isn't some transient kind of phenomenon. This is something that is repeating possibly from the same spot in space over and over, which is a clue as to what might be causing this. Now, also something happening repeatedly in the same spot allows us to kind of pinpoint its origin. In this case, it was a dwarf galaxy over 3 billion light years away.
Oh, that's very far.
That's so far.
That's so that energy was traveling to us, for most of the history of the universe. So it's really far away.
It was
so
right
the
away.
obvious question is, the obvious question is, what's causing these extreme bursts of energy? I got some bad news. Unfortunately for us here today,
Kirk,
the origin of FRBs remains one of the biggest mysteries in astronomy. But I will tell you, there are several intriguing hypotheses on the table, and we have some really good evidence. Okay, so it's not like we have no idea. We've come a long way since these were first discovered in 2007. A lot of ideas have been put out there. One idea is that these are black hole interactions. So some scientists propose that FRBs could be the result of interactions between black holes and other stellar objects. For instance, like when a neutron star gets too close to a black hole, it might be torn apart and release this burst of energy that we detect as an FRB. The trouble with that is that we need to find FRBs associated with black holes, and we haven't really done that. Also, if a neutron star was to be just like torn apart, is that a one-time event? Is that an ongoing thing? Like, how do we explain these repeating ones that we're now finding? Same kind of problem with this one, but a theory was that the FRBs could be the result of cosmic collisions, which is obviously going to give off an enormous amount of energy. For instance, if there was a merger between like a neutron star and a white dwarf that crashed into each other. Again, like I said, similar to the black hole theory in that it involves an interaction with two objects, but also, and both these have like massive gravity wells. Yeah, but that's a one-off thing, right? It's not repeated, and we've definitely seen some of these repeating. So probably not like a cataclysmic event like this, although that could definitely release this level of energy. One of the ones that, of course, scientists will say, well, we can't rule it out, but the media love to jump on was, what do you think? Aliens, of course. Well, when you receive a strange signal from space, one of the answers people will always jump to is aliens. And look, while it's probably not the most likely theory, it is something we would need to rule out. I mean, we do actively monitor space for signals, hoping we might pick up some sort of techno signature from an alien civilization. The universe is vast, and the odds are that there is other intelligent life out there somewhere. So it is a hypothesis that needs to be considered. I love Carl Sagan's line from Contact: if we're the only ones in the universe, it's an awful waste of space. So according to this idea, FRBs might be powerful beams used for propulsion or communication. Kind of cool idea. It's intriguing, and I guess we haven't totally ruled it out, but all data so far points to it being a completely natural phenomenon. Okay, and we're seeing this all over the sky. So it's not like one civilization figured this out and like is tootling around their, galaxy doing stuff. It's like, no, we're picking this up all over the place.
It could be multiple civilizations
who all happen to come up with the exact same technology. Yeah.
Maybe they're in contact with each other, not. Kirk. What if they're trying to reach us?
And we're just left out.
This is the only way they can
with their
reach
millisecond long
radio
bursts. Yeah. I mean, not the best way to do it, probably. But that's the kind of thing we need to theorize, like what would happen. Now, the leading candidate for what these are is something called a magnetar. And I haven't talked about those. I know all the space stuff on the episode. Basically, I talked about something very similar. I talked about neutron stars back in episode 7, which is a really cool episode. Go check it out.
Yeah.
A magnetar is a neutron star, but it's a neutron star with an extremely strong magnetic field. And these magnetic fields are theoretically so intense, they can cause star quakes on the magnetar surface that could release a colossal amount of energy in the form of radio waves. And some research has shown that the signals of FRBs are polarized, which could only happen if they had passed through an extremely powerful magnetic field from something like a magnetar. So that's
how
like
can a radio wave signal be polarized? I don't understand.
Neither do I, frankly, but it can be apparently.
Great question.
Yeah, I'm sure we could do a deep dive on just that. But apparently radio waves can be polarized, which is kind of cool. So researchers have also detected now FRBs at the exact same time that they've detected gamma ray bursts from known magnetars. And the signals seem to come from the same place in space. So you're like, okay, all right, we're honing in on this. There was actually also a recent discovery of an FRB-like burst from a known magnetar in our own galaxy. And that made a lot of people say, well, okay, that's it. There is our answer. FRBs are some sort of phenomenon. We don't totally understand how yet, but they're being caused by magnetars. But there's one problem.
Okay.
It's not so simple.
This
is a mystery that won't be solved so easily, and that's because some of the data and conclusions, at least at this point, seem to contradict each other. And here's two examples that this is brand new. This is just from the past year. These are both from 2024. So in 2024, an international team of researchers looked at data from one of the repeating FRBs and concluded that the signal comes from a plasma bubble around young magnetars. And this bubble, or like essentially a nebula, is what actually causes the radio discharge. So somehow this sort of nebula around this is what's actually giving off this radio signal. They did all the math, all the theoretical stuff, and it looks pretty compelling. So it's like, all right, cool. More evidence that this is what this mysterious signal is it has something to do again with the magnetar. Now they're trying to like hone in on what is it that actually creates that signal. Interestingly, that totally contradicts the previous thing I just said about it being caused by these star quakes. And they're like, no, it's not that. It's this plasma bubble around the magnetar. It's like, okay, so there are different theories out there, right? But then last summer, astronomer Kelvin Luong was looking at data using a cool new technique that let him pinpoint the location of bursts better. And things got weird because he pinned down the location of a burst, but when astronomers looked at the spot with optical telescopes, all they found was an ancient elliptical galaxy that's often considered to be called like a dead galaxy because it's so old that there are no new stars forming there. And to make matters worse, the burst was from out near the edge of the galaxy, which is an even less active region of galaxies. And this is a place where we would not expect to find magnetars. They are in like hot, dense, new star forming regions, not in old, dead galaxies where no stars are being formed, and then way out at the edge of an old, dead galaxy where there's definitely not new stars being formed. So we're like, okay, what does that mean? And what it could be is that there's more than one explanation for FRBs, and maybe multiple different types of events are causing similar types of signals. Yeah. So clearly, we have a lot left to learn, and while that can be sort of unsatisfying to not have a neat, tidy answer, I think the quest to understand the unknown is what drives science, right? Our curiosity drives us to ask better questions and figure out new ways to discover the answers and to come to better understand the universe and the world that we live in. It is one of the truly most exciting things that we can do as humans. So it's really cool when you discover something new like this, whether it's a new species, a new bacteria growing on the Titanic, whether it's something way super far away in space that's so challenging to even figure out how to discover. These are things that drive us forward as humans and help us just understand the entire universe and someday ourselves better. So I think it's really cool to learn about these cutting edge things that we maybe don't totally understand yet. So totally. That's what I have for you this week. A mystery, a cosmic mystery from space, fast radio bursts. My sources were the journal Nature, Wikipedia, Science Daily, and Scientific American.
Thanks, Kirk.
Awesome. Thank you so much, Kirk.
Absolutely. Well, you know what? I think that's,
That's it for the day.
That's everything, isn't it?
Yeah.
That's the show.
Yeah.
We did it. We made it to the end. You made it. Thanks so much for listening. We love our all of our folks who are you're supporting us. It means a lot to us for you, even just to be there. So thanks so much.
We'll
Bye.
Have a
see
great
you
night.
next week.
Bye-bye.
Bye.
Thanks, everyone, for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all our listeners. If you would be so kind as to leave us a 5-star rating and review wherever you get your podcasts, that would be great. It lets other lovers of the strange discover the show. You can reach us by searching for Strange by Nature Podcast on Instagram, Facebook, and Blue Sky. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can check out our website, strangebynaturepodcast.com, and you can support the show and get ad-free episodes at patreon.com/strangebynature. Until next week, get outside, stay curious, and embrace the strange.